So thank you everyone for coming to hear me talk about caching Craft. Originally, I was going to actually come down to London and speak to some of you in person, the ones that would actually have been in London. However, things obviously took a turn for the strange, and so we've ended up doing this remotely. It's the first time I've done a remote presentation like this, so bear with me if I don't know what I'm doing, because I don't. I'm going to talk about caching Craft at kind of a high level today. I don't want to go really deep into the innards of how things work, because there's a diminishing return on how far people go into the different levels of caching that are involved. You could go all the way down to caching within the operating system and caching on the file system and things like that, but we don't want to go there because we'll just leave the operating system to handle that. So we're going to look at some of the high level caching things that you can do with Craft and the pros and cons of each of those different methods. So the first question we have to ask ourselves is why we're going to cache in the first place. I mean, you can put a lot of effort into caching, and the reasons behind why we need to cache in the first place will both inform how we go about doing that caching and also inform which caching methods we actually want to implement, because that will depend on certain variables within our existing infrastructure. So one of the reasons that we need to think about caching is that Yi, which, as I'm sure you all know, Craft is based on, isn't a perfect framework. And by perfect framework, I mean a framework which responds in 0 milliseconds for all requests. There is some level of overhead for every single request that passes through Yi. Craft also isn't perfect. There is a certain amount of overhead that exists for every request that passes through Craft's code base. And what that means in general is that every single request that comes into our backend server is going to take some amount of time to compute. Even if we have the most simple website that just serves some static template file, it is going to take a number of milliseconds to actually process that and send it back to the user. And all of that time per request adds up, essentially. And we can do a calculation to show a grossly oversimplified calculation, because it is actually a lot more complicated than this. But essentially, if we have a page built in Craft, it's not unusual for that page to use 300 milliseconds worth of server-side processing in order to figure out all the content that needs to go into the page, perform different transmutations on that content, and then send it back to the user and do all the other stuff that Craft does as kind of its response cycle. In essence, that means that if we were to receive 4 requests, they would take a total of 1,200 milliseconds, so just over a second to actually process all of those requests. The reason I specifically stated that this is a grossly oversimplified example is because this is assuming that all of those requests are processing serially, and there's no parallel processing, which is not usually true for these things, but computers are complicated, so we won't delve too deep into that. We'll assume that 300 milliseconds times 4 equals 1.2 seconds, which means that if we end up receiving 4 requests a second, we're going to be trying to process 1.2 seconds worth of stuff every second, which is obviously slightly more than time allows. So we'll end up with something bottlenecking somewhere. At this point, it doesn't really matter what it is that's bottlenecking. All we know is that the requests that are coming into the server are going to take longer to process for some reason than the amount of time that is available to us. And you might think to yourself, if I'm receiving 4 requests a second, I'll be rich anyway, because you'll be the most popular blog on the internet. That's fair, but in my experience, 4 requests per second isn't something that we can model particularly accurately, especially when we start thinking about how requests can multiply by themselves. And what I mean by that is that when a user loads a page, it's not unusual for that page to make AJAX requests back to the origin server, which multiplies that one page load by however many AJAX requests there are. It's not unusual for plugins to make AJAX calls back to the origin server to load their content or to do additional processing in the background. And we also have to think about redirects as well. A certain percentage of page loads on a traditional site will end up redirecting to another page as either a 301 or a 302 redirect. That 302 or 301 likely will go to Craft first, and therefore it will use up some processing time before it redirects to another page, and then use up more processing time in order to actually render the page that the user intended in the first place. So with redirects, we're also multiplying our calls back to the server by 2. And also then you might have a web dev on your team, which has implemented the entire website using old school frames, in which case every single frame is a call back to the server. And depending on how liberal he has been with his 1999 technology, that might end up with like 6 or 7 simultaneous requests back to the server. And already, just with one page load in that circumstance, you've hit your 4 requests per second threshold. So I've recently been working on a site which I had to do some diagnosis on, because every now and again it was receiving requests that would come in a big spike, and those requests would top out at about 60 hits a second. And normally this site would receive probably 2 requests a second on average. So this big spike of 60 requests a second was kind of out of the ordinary. And when that big spike came into the server would fall over pretty much straight away, because PHP would just throw a fit, essentially. All the requests were for URLs that didn't exist as well. So all of these 60 requests per second were rendering the 404 page, which Craft was dutifully rendering and sending back for all of the requests. The 404 page contained a list of this. It's said at the top, this page doesn't exist. Maybe you would like to read these articles underneath. These articles were generated dynamically based on the latest articles that had been published to the site. So essentially the 404 page was dynamic and had to be served individually to every single user that hit that 404 page. So these 60 requests per second for random URLs were essentially asking PHP to render 60 dynamically populated pages within 1 second, and it couldn't cope with that. We actually ended up looking into the logs. Well, first we thought it was a bot, because we looked in the logs and we could see that it was just requesting loads of random image files, and they were actually hitting the 404s. We started by trying to block the IP address, because we thought this must be some sort of bot or something that's trying to take the site down or trying to index too quickly. So we used Cloudflare to block the IP address, but then after a few days the IP address would change and the same pattern would start occurring, and the site would start going down like 2 times a day. So we decided we were going to do a bit more forensic analysis of this. We had a look through the logs that the site was generating, and there was a common theme with the URLs that it was requesting, in that a lot of them were related to emails. So they either had email in the URL, or they had something like signature in the URL. And what we essentially figured out was that at some point in the past, somebody had created some email signatures and some like images that people put in the bottom of their emails. And that had become the standard template for the company whose website this was. They'd then used those signatures over a number of years. And then at some point, they'd rebuilt their website in Craft. However, these images, which are referenced from the old website, hadn't been carried over to the new Craft site. So whenever one of the management staff in this company opened an old email thread which had a lot of replies, that would then try to request for every single reply in the email thread the same signature images from all of those things, and that would essentially DOS the server as it currently stood. So we had to come up with a roundabout way of either stopping people from requesting those images in the first place. What we actually ended up doing was putting some placeholder images in where all those old URLs were, so that they would just be served empty images, so it didn't break people's email clients. But it just goes to show that even when you're not expecting people to send you lots of traffic, there are some strange circumstances that can occur where you will receive 60 requests a second. And when that happens, you'd better be caching your 404 page. He found it funny. So how does caching actually help in this circumstance? If we imagine a very high level diagram of how our traffic passes through our system, we can imagine a user request will first pass through the infrastructure, which is kind of the internet, essentially. It might have CDNs, it will have network switches, it'll have all sorts of hops between the client and our actual web server. Next, it will drop into the web server, which could be Nginx, it could be Apache. And then that will then forward the request to PHP. So we've got several opportunities within that flow to implement caching. And each of the different levels has different pros and cons for different reasons. We can, often the easiest solution is to cache within PHP itself. We can not only cache to prevent requests from reaching our PHP processors, we can also cache within PHP itself to statically render individual parts of pages. So we can, by differentiating like that, we can both reduce the time it takes per request by caching, as well as the number of requests that we have to serve. So by caching within PHP and caching individual portions of pages, we can reduce the amount of time that it takes to render an individual page so that we can process more requests per second, essentially. We can also cache within our web server, so within Nginx or whatever we happen to be using as our web server. This allows us to cache entire pages. So I'm sure lots of you will have done this before by caching full page responses from PHP and then serving those back to the user. This is essentially reducing the number of requests that are reaching PHP. So we're increasing our throughput by decreasing the number of requests that we're actually processing. And similarly, we can cache within the wider infrastructure. And probably the easiest way to implement this is with something like Cloudflare, where we cache within the network layer. And by doing that, we don't even have to worry about the requests hitting any of our stuff at all. So it becomes someone else's problem, which makes this one of the nicest solutions, because we don't have to worry about scalability. We just hand it off to someone else and say, you cache this. The content might grow, it might shrink, there might be more of it, there might be more requests coming, there might be less requests coming. We don't care because it's your responsibility now. But that comes with trade-offs, which we'll go over later. So first, we'll have a look through the pros and cons of specifically caching with PHP. So first of all, it is super easy to implement when using Craft. Craft gives us this lovely cache tag, which we can use in our Twig templates. By including that in those templates, we kind of get caching for free, roundabout, given some caveats, which I'll cover in a minute. Anything within those cache tags will get written to the database, and then it will get pulled from the database whenever that page is rendered in the future until that cache expires or is busted by Craft's native cache busting system. So it's really easy to get started with and is a really good place to kind of begin trying to cache a site that needs caching. One of the prime benefits of using Craft to do this and using the cache tag specifically is that caches don't have to be directly linked to URLs, which is a really big thing that is quite often overlooked. By default, the cache tag will link a cached block to the URL that was used to access that page. However, that's not needed necessarily. You can add the globally keyword to the cache tag, and that will disassociate that cache block from the URL that was used to access it. And that's super useful for doing caching on global elements across sites, such as global headers, or elements that are shared across a subset of pages. For example, you might have a trending bar within a site that's got lots of different pages, but the trending bar needs to be the same on every single page. Using the cache globally allows us to disassociate that cache block from the URL that was used to access it, so it can be cached across lots of different URLs. It's also content aware, so these cache tags are aware of the content that is being rendered within them, and that allows Craft to intelligently invalidate the cache, so cache bust. I've said easier because it does cause problems occasionally. But one thing that Craft does have to its advantage is that you can bust the cache that is relevant to a specific entry whenever that entry is saved, which is really cool, but has caveats. Also, I noticed that Ben's hiding out in the background somewhere, but there is also plugin support to extend the Craft functionality. And not only extend the Craft functionality, but also improve upon some portions of Craft's inbuilt caching functionality. Blitz is a really good plugin for this, and it will not only cache, it will not only implement similar functionality to Craft, but it will also extend that to kind of meld into some of the other steps that I'm going to talk about later. And also plugins like cache flag, which allow us to tag different cache blocks with a keyword, so then you can invalidate big chunks of blocks all in one go, which is really useful for if you say save a global within a Craft site. That global might affect a number of pages, and you want to invalidate all of those pages whenever that global is saved. So cache flag can do things like that for you without extending the actual the way that caching works under the hood with Craft. So those are some of the good things about caching specifically with PHP and Craft itself. However, it's not all roses. PHP is still executed on every single request when you are caching with PHP. So I spoke about earlier the fact that Yi isn't a perfect framework and Craft isn't a perfect framework. They actually have a small amount of overhead just for processing, just for receiving a request, booting up those frameworks, booting up all of the plugins, allowing those plugins to run through their initialization scripts before it will even move on to reading the cache and serving it back to the client. So depending on the settings that you have in Craft, and depending on the number of plugins and those plugins settings, you can still have a significant overhead, even if you've got essentially a fully cached page when you're serving caches from Craft. Also, Craft's, I've said it about 6 times already, but Craft's native caching can cause problems. It uses the database as its primary storage, which means that even though you've cached an entire page, that page might contain 6 or 7 cache blocks. Each of those cache blocks has to interrogate the database in order to get the data out and serve it back as part of the page. There are more performant solutions than storing caches in the database. There is a conversation on Stack Overflow where Brandon actually talks about why they chose to go that route. And it's essentially to do with cache busting. Craft maintains a relationship in the database between every single cache block that is generated and the element types that are able to bust those specific cache blocks. And that relationship between the cache blocks and the elements that can bust those cache blocks is what the database is used for. It actually has a foreign key from the cache block to the element types. So whenever the element type is saved, the associated cache blocks will be busted from the cache, or essentially deleted from the database, which is kind of good and kind of bad. It means that there's some work going on in the database whenever a request comes in, even though things are cached. But it's also good because it means that cache can do zero config fine-grained cache busting. So it can figure out exactly which cache blocks might be affected by a specific save of an element within the Craft control panel. Another bad thing, and this is normally the one that catches people out, is that within that database storage, the number of rows is based on the number of cache keys, which is, it can be a big number. The cache keys are a product of the number of unique URLs that are used to access your pages, multiplied by the number of cache blocks on those pages. So cache keys itself can be a big number, but that's also multiplied by references to elements within the cache blocks. So if you have a cache block that references 6 different types of elements within your Craft install, that will immediately have 6 different database records. If that page is then accessed via 20 different URLs, you then have 20 times 6 rows in the database that sort out all those relationships between elements and cache keys. You can mitigate this to some extent by setting the globally keyword on your cache tags, which reduces the number of cache keys. However, it can still build up to a really big number. And if you have a website that has, say, 20,000 unique pages, then just adding a single cache key can just destroy your database like pretty much immediately, because the number of rows that are generated within the cache blocks table in the database can just absolutely explode. And I've had that problem before, and we ended up just turning off all of Craft's caching because we couldn't find a nice way to get around it without completely redoing all of the templates. This problem can be somewhat mitigated by actually disabling the functionality which tries to keep a reference between the cache blocks and the elements which were referenced within those cache blocks. And you can do that by just setting cache element queries to false in general.php. The side effect of that is that you lose all of Craft's built-in cache busting system, so it can no longer figure out when an entry is saved which cache blocks should be busted in the database at that point in time. But sometimes it's just necessary because the performance, especially when Craft will perform a background task periodically to try to figure out which cache blocks need to be busted whenever something is saved. If you've got many, many thousands of rows in that table, it's not unusual for there to be millions if it's an unoptimized site. It will just chug away just with 100% CPU on the database while it's trying to figure out which blocks it should be invalidating. So quick fix for that is just disable the cache element queries in general.php. So those are some of the bad things. And it's time for a quick demo. Hooray. Worth noting that some of the internet has fallen over tonight. DigitalOcean have been sending me lots of updates to say that one of their ISPs has unplugged something they shouldn't have unplugged. So there's lots of warnings on the DigitalOcean status page at the moment. So hopefully this is going to go okay. If it doesn't, I blame them. So this is a quick page that I just put together. I'm going to activate the status bar and show the kind of overhead that's generated by just Craft and Yi for every single page request. So I'm just going to make sure that the debug toolbar is activated, which it is. There we go. So this page is just a static template, but even with just a static template, this is very much dependent on your hosting environment, but within this specific hosting environment, which is served, the time taken to process this static page is 41 milliseconds. And you can see that Craft and Yi are still doing 14 database queries just to render a static template. And that's kind of the overhead that is generated for every single page request, no matter what is being rendered as part of this website. So we can extrapolate from that. Thanks, Ben. Can you not see it at the bottom? Can anyone else see the debug toolbar at the bottom?
I can see it.
It should be. Okay, cool. Just you, Ben. Thanks, everyone. So we can extrapolate from that 41 milliseconds processing time that we would be able to handle, quick mental maths, about 25 requests a second. And this is just pure framework overhead. It's worth also mentioning that in the background, this has also been optimized with fast CGI caching as well. So the actual PHP scripts are already cached in memory. So this is a pretty well optimized page that's just rendering a static template, and it's still taking 41 milliseconds. So that kind of sets us a threshold for how we can assume that our hosting is going to perform even under kind of modest load. Maybe 25 requests a second isn't modest load. But we can also have a look at a page which has some actual content. So this is a very contrived page which just spits out some text. So this portion of the page is just spitting out some text in a redactor field. This portion of the page is spitting out some text from the same field, but with some processing applied to it, because I just wanted to use up some CPU cycles. And then we're doing some database queries to grab the image that's output there. And then that's just looped over several different elements of a matrix field. And we can see it's, I've used a deprecated function. It's very poor of me there. But we can see that immediately it's bumped the time taken to render the page up, not significantly, but it has essentially more than doubled our, or just about doubled the time it's taken to process that page. So with a very small amount of content, we've bumped that time taken to process up to 80 milliseconds. We can show the actual impact of using a cache tag by, I'm just going to enable this as an environment variable. I'll need to refresh that page. So I'm just going to activate Craft's cache tags, which will hopefully show us a small speed improvement over this 80 milliseconds and bring us a little bit closer to the 40 milliseconds that we saw for the pure framework overhead. So I'm just waiting for that to sync in the background. And then we'll give it a refresh and see what we've actually achieved. Hopefully we'll see the number of database requests go down as well. The first refresh will likely be a cache miss because I've only just activated the cache tags, and then the request after that should be a hit. Craft has decided not to show me the debug bar. Let's just make sure the cookies are set. Oh, it's not playing. Does anybody else ever have that where the debug bar just randomly doesn't show up?
Yes, I've had that.
Try again. No, so much for doing a live demo, eh? Let's try it. It's just not playing. You go through your live demo beforehand and everything works perfectly. Let's try deactivating it. if this fails, I'm just going to fall back to using the Chrome inspector, which obviously isn't as accurate, but oh, great. Let's fall back to this. So this is going to add 30 milliseconds-ish onto the overall processing time, which is the travel time, the round trip time from Manchester to Amsterdam, which is actually where this is hosted. So we can see if we subtract 30 milliseconds, which is the round trip time, from this value, we get all the way back down to 40 milliseconds. So by implementing that caching within PHP on the back end, we've brought the processing time back down to roundabout where it was for the overall framework booting time. And that should be, yeah, we can see it moves from 60 milliseconds to above 70 on each page refresh. So it's saved us a bit of time, a few milliseconds. I've got more demos lined up for this project. I know that every single one of them isn't going to work now, so that's good. Hopefully it'll just magically start working halfway through. Let's talk about caching in the web server instead. Make me feel better about things. So another option we've got is caching within the web server itself. So caching within Nginx is probably the one that you're going to want to use. Other alternatives for caching at the web server layer might be to use something like Varnish, which is another service that can be used as a reverse proxy to cache responses generated by PHP and serve them back to the user whenever a specific URL is requested. It's easy-ish to implement if you're setting up your own server manually. As an example, there's a lovely DigitalOcean article that tells us how to do this. And the example file that they've given to us has 4 lines that need adding to an Nginx config to get this working. The first 2 which tell us how the cache is going to work and also what the cache keys are going to look like, so how the cache is actually going to be stored and how those reference the URLs that come in to Nginx. And then simply an activation, a couple of lines to actually activate it. So it's easy-ish. You just have to add some lines to your Nginx config. But there are some caveats to that. One of the main ones is that if you're using a provisioning tool, such as Forge or Server Pilot, it can get a little bit more complicated because you have to work around the way that they implement different servers. So Nginx can have multiple servers within a single physical server. So the way that Forge and Server Pilot will actually split the Nginx config up into multiple different logical servers means that it can be a little bit more difficult to figure out where your settings should go and how they should be set. However, it's still doable. And all of these services also give you the option to manually edit the Nginx config anyway. So sometimes it just takes a bit of trial and error, or finding an article on the internet somewhere that just tells you what to copy and paste into there. It's really fast. Nginx and Varnish are designed specifically to receive a request and stream data from the file system or from some other byte-based storage back to the user. So they can process these cached requests super fast, like in the order of tens of thousands of requests per second on modest hardware. So it is many orders of magnitude better than deferring each of these cached requests back to PHP and allowing PHP to boot its frameworks, which add all that overhead. As I've just said, PHP is not involved at all, so there's no framework overhead. Yi doesn't have to boot. Craft doesn't have to boot up. None of the plugins will boot up. None of them will run their initialization scripts, which leads to much better resource usage. So the amount of CPU and the amount of memory that's actually used for each individual page request is reduced by a lot, by many times. And again, there's also plugin support at this level. which helps us implement and extend different pieces of functionality. Blitz, again, is can be used for this. Blitz allows us to cache using PHP, but serve those cached files using our web server, so using Nginx or Apache. Downside of using Blitz for this is that it requires custom config within the web server layer in order to reference the files that are generated by PHP. So Ben's done a good job of documenting how all this works, but it is specific to a Blitz implementation. So once that's in there, you're using Blitz essentially. Other alternatives for plugins at this level are plugins specifically for Nginx. So things that are notable are plugins like SR Cache, which is a lot less popular than it should be. SR Cache is an extension for Nginx, which allows you to write custom scripting for caching within the web server itself. So you can do things like create custom cache storage engines. So you can push your cache files to Redis, or you can push them to Memcache, or you could store them somewhere around. You could store them in S3 if you wanted to, and then read them back in and serve them to clients. I wouldn't suggest storing them in S3 because that would be horrendously slow. Also, you can write pure Lua scripts for Nginx as well. So Nginx has the ability to write just arbitrary scripts as part of its framework. They're all written in Lua, which I had never written in before I started writing Nginx scripts. But it's quite expressive, and there's lots of plugins that are available that incorporate into Lua itself as well. So you can really expand the logic that's used to process every single incoming request into an Nginx server using Lua, and then use that additional functionality to implement all sorts of crazy caching schemes. So you could cache pages which have an MD5 that starts with the letter A. You could do that if you wanted to, or you could cache based on some random thing like if the user's IP address looks like it's from the Ukraine, then serve them a different cache compared to everyone else. It allows you to do really complicated logic things like that. Again, it's not all happy days. When you are caching at the web server layer, the web server isn't aware of the structure of the content that's held within Craft. So it's not content aware, which means that cache busting either needs to be implemented manually or it needs help using some other mechanism. In the case of using Blitz as a plugin in Craft, that can actually help with cache busting in this scenario because the Blitz portion is content aware because it's running as part of PHP, but the web server isn't. So we can get Blitz to do the cache busting and the web server to serve the content. So that's a good combination of the two. There are also other cache busting techniques that you can use within Nginx itself. However, they can get quite complicated. Nginx Pro, the paid for edition of Nginx, I think it's called Pro, whatever the enterprise edition of Nginx is called, actually has an API built into it, which allows you to make calls from your backend application to invalidate specific cache files. So you can still get your content aware PHP layer to invalidate Nginx Plus, thank you, which allows your PHP content aware layer to still invalidate caches, even though the caches are being generated and stored by Nginx. Also, exceptions to your cache can be a pain to manage if you're implementing this at the web server layer. In Craft, it's easy because Craft just assumes that caching is off by default. Caching is only activated if you add a cache tag to a page. So the default is no caching. However, when you activate caching in a web server, it normally defaults to on by default. So having to list all of the different possible exceptions to those caching rules can be a bit of a pain, especially when you have to like update config files for Nginx and then restart Nginx so it loads in the new config files and things like that every single time you want to add an exception rule. Again, there are methods of getting around this. You can do like dynamically loaded config files for Nginx, but it requires a lot of knowledge of the life cycle of Nginx itself to be able to do that properly, so that you don't start dropping requests when Nginx is rebooted and things like that. So it can become more of an issue if you do have lots of individual exceptions to your overall caching strategy. It's also not, if you're using the web server for doing caching, it's also not Craft aware. And by that, I mean that Craft implicitly knows certain things that are intrinsic to Craft, like when a user is logged in, for instance. Craft knows that if a certain cookie is set with a certain value, that user that made that request is logged in, and therefore certain things should happen, like give them access to the control panel, and certain things shouldn't, like if an admin user is logged in, maybe we shouldn't cache some of the things that are rendered for them. Whereas the web server has no knowledge of how Craft is working behind the scenes. So it's very easy, once you switch on caching in Nginx, to accidentally cache things that should be admin only, or should change depending on the user or the specifics of the request that PHP would otherwise be aware of. I've seen examples of this in the past where there was a website where if an admin was logged into the control panel, it would show additional statistics on the front end. So it would say, like, this page has had this many views as like a little added extra bit of info on the front end, or click here to edit this page as a link at the top of the page, but only for admin users. Once caching was switched on, that started getting served to everyone, because the cache request happened to be generated by the admin user, so it included those little bits of extra information. So that's one that's really key to keep in mind as well. Also, caches tend to be URL based. We can see that from the example that I showed you of how to actually implement that in Nginx. So here, I'll just zoom in a little bit. This tends to be the line that the majority of people use when they're implementing caching in Nginx, which tells Nginx how to differentiate different caches based on the URL that's coming in from as part of the request. And essentially, it's just saying HTTP is a GET request. The host is usually the same. It's just the domain name that was used to request the page and the request URI. Those are the only pieces of information that are used to differentiate one request from another in terms of which cache is actually served. Craft can do a lot more than this. You can say, like, put an if block in a template and say, if the user is this type of user, then cache this block or serve them this particular cached block. Nginx isn't aware of any of that context around the user or any of the context that Craft kind of implicitly knows about. All it can use is the structure of the HTTP request that's actually come into Nginx, and predominantly that would mean the URL. And the knock-on effect of that is that all of the caches within Nginx are linked to specific URLs. The bad side of that is that we can't do sub-page caching. So unlike Craft, which can cache 6 different parts of a single page and serve them back for one URL request, Nginx isn't able to do that. It will just cache the entire thing, and that becomes a kind of a blob, which is either served or it's not. Whereas cache can invalidate individual blocks depending on what's saved in the background. It can also serve different blocks to different people depending on the type of user, as I mentioned. Again, there's ways to get around this. You can use something called server-side includes within Nginx. This allows Nginx to break a single URL request down into multiple blocks as part of the response. And then it can make individual requests for each of those blocks back to Craft in order to kind of create dynamically built pages using Craft as the back end, but for a single URL. SSI is really interesting to look into. Sometimes it can be quite difficult to get right and get it to act the way you want it to. And it also doesn't come for free. As I mentioned earlier, when I was talking about the number of requests can multiply when you do things like make AJAX calls, SSI and Nginx is very similar. in that a single request will come into Nginx. Nginx will then split that into multiple requests to the Craft backend in order to generate its dynamically blocked response. So naively implementing SSI to inject dynamic content into otherwise static pages, otherwise cached pages, can result in the big bloat in the number of requests and therefore the number of times that the PHP frameworks are booted for each individual request. Also, when you're caching in the web server, it's difficult to bust caches using anything other than that specific URL. You'll have likely seen this in, if you've ever used Cloudflare before to do caching at that level, you have to bust your cache based on specific URLs. It's really difficult to use prefixes to do cache busting. And it's the same with caching at the web server level. You have to essentially give it the specific URL that you want to bust. If you don't give it a specific URL, then it can't bust like groups of different caches. So it's difficult to do things with tags or based on prefixes, which Craft is able to do if you are using plugins, which make that easy. So another demo is guaranteed to go wrong. I'm going to activate static caching within the same project that I was running. And normally we'll be able to see the request time go down because we are essentially removing all of the overhead that's generated by Yi and Craft booting up their frameworks. So currently we have our content page, which is cached in Craft using a cache tag. It's just taking 63 milliseconds to render there. 73. So we're still in the 60 to 70 milliseconds realm. Hopefully, if we activate static caching for this and then sync that in the background, once that's done, we'll actually be caching the page response within Nginx itself. So all of the requests will be foregoing the hop to PHP, and therefore we should eradicate the Yi and Craft boot time, which we established was between 30 and 40 milliseconds in our first test. So we'll get a cache miss first. I'm just going to give this another 30 seconds or so to make sure it's sorted itself out in the background. But we're expecting our 60 to 70 milliseconds to drop back down to 40 milliseconds-ish because we've removed Yi and Craft's boot time. Let's give this a go. So that was doing something that will, because the container's refreshed within the hosting platform in the background, that was starting the PHP worker children and refreshing the fast CGI cache. The next request, I was expecting it to be slightly lower. And this is the pain of doing it through Chrome's inspector because we're not actually seeing how long PHP is taking to process. But oh, no, it's not. It's me being an idiot. So I've written on my list of this is how I'm going to do the demos and the things that I'm going to call out. I've got a big thing that says, make sure you log out of the Craft control panel before doing this demo, because the caching, the static caching within Nginx has an exemption rule for if a user is logged into the control panel, which is why you might be able to see on your screen we have a cache bypass there, which is why it hadn't dropped in terms of how long it was taking to process the page. So let's do what my instructions actually say I should have done and log out. And there we can see our, our request time has now dropped down to 33 milliseconds, which is exactly what we were expecting. We have the 30 milliseconds round trip time from me to Amsterdam. plus 3 milliseconds, which is the Nginx processing time roundabout. But we've eliminated the Yi and Craft 40 milliseconds overhead for booting those two frameworks. So that was actually quite a successful demo, actually, other than not following my own instructions. So we've shown how each of the different elements of caching that we can do within those two components can affect our processing time. And we've managed to actually demonstrate that the amount of time you can save for each of those different steps is somewhat deterministic. We actually made a pretty good prediction of how much time the frameworks were using to boot in the first place. And we saw that we eradicated all of that time when we implemented the caching within the web server layer. So our third option, and in some ways the best and in some ways the worst, is caching at the edge. So this is caching within our actual networking infrastructure. The easiest way to achieve this is to just stick Cloudflare in front of your website and allow Cloudflare to generate the caches and serve the caches to your users. So that's what we're going to be talking about. We're going to be in the context of Cloudflare. It's great because the requests are mostly handled by someone else. A single request will travel all the way through the network to your backend server. That will get processed as normal, but once it returns back up that stack, it will hit Cloudflare. Cloudflare will cache that request, and all subsequent requests will be served directly from Cloudflare's CDN, which sounds great. We've outsourced all of our scalability concerns. I've said some of our scalability concerns. You still have to make your website actually load within a reasonable amount of time for that first request. But subsequent hits, we don't have to worry about anymore because they end at the CDN. We've also given ourselves DOS protection, because it's one of the things that Cloudflare like to sell is their DOS protection for sites that sit behind their CDN. So we kind of get some stuff for free as well by implementing caching at this layer. We also get the benefit that the content is distributed on a CDN. So I've been speaking about the round trip time from my computer to Amsterdam, which is where the test page that I've been using is actually hosted, as being 30 milliseconds. But that 30 milliseconds is going to be different for someone else. If you're in London, it will be less than 30 milliseconds. If you're in South America, it will be a lot more than 30 milliseconds. Cloudflare's caching is nice because the cache is held within their CDN network, and their CDN network spans the entire globe. So even someone who is in South America, if they make a request to my server in Amsterdam, but the content is served from a CDN node, it's likely that that CDN node will be in South America as well. So they get the same low time to first byte that I have enjoyed so far in my testing with this website. It means that it's geographically closer to users in that way. It also means that it's topographically closer to users in that there are a lot less network hops between the user and the server that actually serves them back the content that they've requested. This is good because the internet is not infallible. And as I mentioned at the start of this talk, there's currently, I'm not sure if it's still ongoing, but DigitalOcean have been telling me tonight that an ISP has gone down somewhere, which has made transatlantic connections a bit flaky tonight. And reducing the number of network hops between a user and the content that they're requesting is good because it makes them less exposed to all the potential things that can go wrong in the massive mesh network that is the internet. So both geographically and topographically closer are plus points. It's also probably the fastest solution for time to first byte. For those two reasons, essentially, if you make a request and it goes to the Cloudflare network and they return you some cached content, it's going to be really quick. It's going to be a lot quicker than if you are hosting a site in a random data center somewhere in the world. And that's because Cloudflare is specifically designed and conditioned for this use case. They've made sure that their nodes are on the internet pipes that are serving the most people the quickest, essentially. So it all sounds great. And as a bonus, it will also intercept all of our static files, and it will serve those from the CDN as well. So not only are we speeding up the delivery of our dynamically rendered pages that would normally go to PHP, but it will also cache our static files, our JavaScript and CSS, and it will cache those on its CDN so they get the same benefits as well. So it sounds like I'm trying to sell Cloudflare to everyone. However, I've got extra things that are good. I'm doubling down on the things that are good about Cloudflare. Also, there is plugin support. I guess I can't go a slide without saying that Blitz is good. Blitz will allow us to take the functionality that cache normally applies to busting its individual cache blocks within PHP and can apply it to busting the cache within Cloudflare as well, in a similar way to it does with the web server setup, where it can bust the cache within a web server. However, it's a little bit nicer, in my opinion, with Cloudflare because it doesn't need any custom setup. It uses the Cloudflare API in a very standard manner to do that cache busting. So there's no custom setup required other than adding a few API details. Also, there's a plugin called Upper, which does a very similar thing. It will track the URLs that need busting within Craft itself each time an entry is saved, and it will call the Cloudflare API to try to bust that cache in the CDN layer. So yeah, as I mentioned, sounds great, but there are some bad things as well, as I've mentioned with all the other layers. Again, it's not content aware, so cache invalidation can't be implemented natively within the Cloudflare layer. It doesn't have an awareness of which entries within Craft relate to which URLs that it has cached within the CDN. So there needs to be some custom logic or a plugin, as I mentioned, Blitz or Upper, to actually implement that cache busting logic to get that to work. Cache invalidation also takes, I've said, some amount of time. In the Cloudflare dashboard, when you invalidate URLs, it comes up with a little message at the bottom that says, this may take up to 30 seconds. In my experience, it takes anywhere from 5 seconds to it never happens. So I've had several occurrences with Cloudflare where I've either needed to bust the cache via the API or via the dashboard itself by invalidating specific URLs. And although it looks like everything's gone well, the cache just doesn't bust. The files are still served from the CDN. And in those situations, I've just had to do a full cache purge. Has been the only way for me to actually get those caches erased from the CDN layer, which isn't always great, because if you are caching because you've got a lot of traffic, and then the only way for you to reliably get rid of one specific URL is to bust the entire cache, then every time you bust the entire cache, you're letting all of the traffic for a small amount of time hit your origin server again, which might knock over your server. And that's the kind of the whole thing that we're trying to avoid in the first place. I've also said, I put often in brackets there. I've experienced this multiple times on multiple different websites to the point where I just don't trust it anymore. I still use it because it's a super useful tool. However, I always try to take some other steps to make sure that if I do have to do a full cache invalidation because of this issue, it isn't going to knock over a website. So great service, and it does lots of cool things for us, but it can do things that it says it's not going to do sometimes, and you have to plan for that. Also, something that quite often that people forget is that the CDN layer within Cloudflare is actually really big. Cloudflare's edge nodes, it has over 300 edge nodes in its network. Each of those edge nodes has its own cache. So if I were to request a page on a specific site that was fronted by Cloudflare, I would be routed through the Cloudflare edge node that was geographically closest to me, which is in Manchester somewhere. However, if someone in Europe on the continent were to make exactly the same request, they would get routed through a different edge node, the one that's geographically closest to them. Those two edge nodes have different caches, and therefore will both forward that request to the origin server in order to get the response to store in their own caches. And this trips people up quite a lot sometimes, because if you have a website with 10,000 pages, you might expect that there will be 10,000 hits against your web server before everything has been cached. However, if you are caching using Cloudflare, there could be 300 times that 10,000. So is that 3 million? 3 million hits against your origin server rather than the 10,000 you were actually expecting. That is assuming that all of your traffic is perfectly geographically distributed. If all of your traffic is in one country, then the chances are you're only going to saturate a small number of Cloudflare's edge nodes. So it's worth keeping in mind that even though Cloudflare is caching on your behalf, it has lots of caches that it will try to fill before it becomes saturated globally. It also isn't foolproof in that it does some things that you might not expect. Cloudflare has a setting that just says cache everything. It doesn't cache everything. It will cache successful requests, and it counts successful requests as requests that return with a 200 or 300 response. 400s and 500s aren't cached unless you set some other additional settings that specifically say that they should be. This trips people up a lot because, as I mentioned earlier, with the bot that wasn't a bot and ended up being someone's email client making 60 requests a second for 404 pages, wouldn't necessarily be cached in Cloudflare for more than a few seconds. So even though you've got the setting switched on that says cache everything, it isn't necessarily caching everything in the way you would expect. Also, something that I have done in the past, and other people I'm sure have done, is accidentally busting the entire cache, which leads to a recache flood. So essentially that's what I was talking about before, where you hit the big button that says remove all of the cache, and then all of a sudden all of these 300 plus edge nodes all start forwarding requests to your origin server. So even though it looked like you were getting, if you were to look at your origin server, it looked like you were getting like 1 or 2 requests a second. As soon as you click that button, that could shoot all the way up to that 3 million that we were talking about before. You also, these kind of somewhat more fundamental points about caching in the infrastructure and using services like Cloudflare. You don't have control over the full infrastructure of how your site is being served. And that has all the usual caveats for when you offload services to a third party, such as if Cloudflare has downtime, your site has downtime. A few days ago, Cloudflare's Argo routing system went down for 6 hours-ish. And that was because their dashboard went down. And for some reason, their dashboard is intrinsically linked to how Argo does its routing across the internet. So Cloudflare's dashboard went down for 6 hours, which meant that Argo went down for 6 hours. And that meant that anyone who was serving their websites via Argo, their websites just went completely offline. It's quite ironic because Argo is sold to enterprise clients. So all of the people who were using Cloudflare for free were all fine. But all of the enterprise clients who had paid the Cloudflare enterprise pricing, which is like $5,000 a month or something, all their sites went down for 6 hours. You also have to worry about policy changes. So Cloudflare at any time can change their policies. It's also worth bearing in mind if you're using Cloudflare for free, these policy changes will likely impact those websites in the most stringent ways. I don't anticipate Cloudflare is going to do anything like crazy and just remove its free tier or start doing something that's horribly security unconscious for its free tier. But you are at the whims of Cloudflare if you're sending all your traffic via them. It's also free, so are you the product is the classic thing you have to ask yourself for free things. Cloudflare can also be a bit overexcited with its banning of people. We don't see this a lot in the more Western countries. In the US and Europe, especially, we very rarely see sites that have been, or very rarely go to a site and Cloudflare says, "Oh no, we think that you might be malicious, so we're going to make you do a really annoying captcha where you have to identify 20 buses in order to get through to this website." However, it is actually quite common for just normal users outside of the US and Europe to be impacted by Cloudflare's captcha policy in front of sites. And depending on where your primary audience is for the website that you've put behind Cloudflare, that could become an issue. And it's one that's not particularly obvious for us when we are actually building those sites in the first place and testing this. Also, it's worth being aware that Cloudflare, although it will cache your content, it makes absolutely no guarantees on how long that content is going to be cached. It does have a setting that says, I would like my content to be cached within your CDN for this amount of time, but they make absolutely no guarantees that it will. What they actually say in their, if you go and dig through how this works, is that you kind of get a best effort caching for everything that's on the free and the pro plans. The business and enterprise plans get a lot better coverage than this. But for the free and pro plans, your caches can get kicked out of the edge cache at any time. So if Cloudflare wants to, or they can just delete all of your cache files from their edge nodes. The reason that that actually might happen in reality is if an enterprise client launches a new website with thousands of pages and they all start getting cached in a really short space of time, then the amount of memory or file system space, depending on how this is being cached within the CDN, gets saturated within a specific node. Cloudflare will prioritize the business and enterprise clients' caches over the free and pro project caches, and it will evict the caches for the lesser plans so that it can make room for the business and enterprise clients. So I've never actually experienced having a significant portion of cached content being kicked out of Cloudflare, but it is always a possibility, and it is part of their policy that they can do that. Another potential point that's worth considering is SSL decryption. So when you are proxying everything through Cloudflare and using Cloudflare as a caching layer, it has to decrypt SSL traffic in order to get the content from your in order to end the SSL connection so that someone can connect to the CDN. It needs to be able to decrypt the content within that connection. They do actually have services now which can do transparent SSL proxying and still do some of the DOS protection stuff, but I've not looked into that too much. But the normal service will decrypt all of the SSL traffic. So they essentially have access to everything that's going to your server and everything that's coming from your server, which includes passwords, it includes API keys, anything like that that's included in the HTTP request, Cloudflare have access to. And this has been a problem in the past. Cloudflare had a security vulnerability 2 years ago, I think, where they had memory leakage in one of their services within the CDN layer, which meant that some of the caches from one project were leaking into the caches of another project. So requests for project number one were returning just random garbage, which was overflow from the cache from project two. And within that garbage contained usernames, passwords, API keys, anything that Cloudflare had cached as part of the HTTP request or response that had gone through its network. And not only that, but all of those requests had been indexed by Google as well. And that's how it was actually noticed. It was Google that picked up on the problem because they saw all these API keys and usernames and passwords being indexed by the Google bots. And they informed Cloudflare and said, your caches are overflowing into other people's caches and it's just spitting out random sensitive data on like other random websites on the internet. So they very quickly fixed that issue. But because they can decrypt your traffic, this is also a problem that can occur in the future if another bug comes up similar to that. And also there's the inherent trust issue. Like you have to implicitly trust Cloudflare in order to allow them to decrypt all of that traffic that's going to and from your server. And you have to kind of think about that trust in terms of your user as well, because your end users are the ones that are sending you your password. And as far as they're concerned, there's a little lock up next to the URL. So they think that everything's SSL encrypted. They think that the client to server connection is fully encrypted because they've got this little lock. But actually, Cloudflare can read all of that data, but the end user isn't necessarily aware of it. So that's something to bear in mind as well. So let's do another little demo and see that working. We'll see how much we can reduce our, what did we get it down to? So we were on 33 milliseconds. Let's see if we can reduce that further with a bit of Cloudflare goodness. So I'm just going to activate Cloudflare proxying for this domain. And then I'm going to wait for that to propagate because it's a DNS change. And then I'm going to use a completely different browser to actually make this request. I'm going to need to pick up the new DNS records. So I'm going to stop presenting and change to a different window, which is this one. So now you should be seeing Firefox instead of Brave, which I was using before. When I make this request, I'm just going to give it another few seconds to make sure the DNS is shifted over. It will pick up the new DNS records and it will proxy the request via Cloudflare instead of going directly to the origin server. And that should pick up some new headers to tell us that that has actually worked. So let's have a look in the network panel. And we just want HTML, please. And let's give it a go. So that took a little bit longer than expected, probably because it was doing DNS lookups, because it's the first time I've hit it with this browser. I'll just make sure it was actually going through. Yeah, so we can see it's got CF headers. It's, currently got CF bypass there. If I give this another refresh, hopefully it's going to say miss. Not sure why it would bypass it. So 86 milliseconds, so that went all the way to the origin server. Not sure why it's bypassing. It is set up to, yeah, the rule is set up to cache everything on this URL. So I'm just going to give it another couple of hits and see if it changes its mind. I guess I should have put this on the negatives list. Sometimes Cloudflare does things that you don't expect it to because you set the rules up to say cache everything and it just doesn't. Give it another go. Oh, classic demo. For some reason, Cloudflare has decided it is not going to cache any of these requests. It's going to bypass them all, even though the rules are set up to actually cache every single request that goes through, which is unexpected. Let me just try the root URL. No, it's just bypassing everything. To Ben, no, because it's a brand new browser. So it shouldn't have any cookies set. I'm just going to deactivate the caching rule and reactivate it again in Cloudflare and see if it makes a difference. Give that a go. Oh, it's decided it is not going to cache. But anyway, no, because I have a page rule set up to tell it to cache everything irrespective of origin cache headers. So it should be caching anyway. And when I was testing it earlier, it did work, which is annoying. But what we should have seen there is Cloudflare would have said hit because it would have hit the edge cache, and we would have seen the time for the request, which let's give this a refresh. Currently 71 milliseconds, which is similar to what we were experiencing before, but that would have dropped down to say 20 to 30 milliseconds ish, because it would be hitting the Cloudflare cache in Manchester, and my round trip time from my house to Manchester is closer to the 20 to 30 milliseconds mark. If anyone wants to hammer those URLs and see if it's caching for them, then feel free.
I've just checked one of my sites on Cloudflare, and it's also bypassing.
Great. So that's just absolutely proven my point that you can't trust Cloudflare to keep your caches or do what you tell it to do. Right. I will stop bothering then to try and demonstrate that.
I'm trying it here, and it's also bypassing.
They must have just switched off their caching for everything for some reason. Well, that was good timing, wasn't it? Let's go back to the presentation, eh? At least my slides work. So yeah, let's just pretend that all that went really well, and we're all convinced that Cloudflare does what I said it was going to do. We have to be aware whenever we're implementing caching at any of these 3 levels that there are some things that don't necessarily go to plan. You can use a common use case for caching like this is that you will serve a static version of a page, a cached version of a page, and then augment it with dynamic content by using AJAX requests back to the origin server. So your AJAX requests won't be cached, but your main page load will. And that is quite a common thing. Examples of when this is used are with Blitz specifically. It has a function called getURI, which allows you to get dynamic pieces off a page and inject them into a page. And also CSRF input, which loads the CSRF token dynamically and loads that into a cached page. There are some plugins in the Craft plugin store as well, which will use AJAX to load the state of a certain UI element. So for instance, upvote is a plugin that uses AJAX requests to get the state of an up or down vote on a UI element. And also, as I mentioned, Nginx SSI, which splits a page into blocks and then requests certain portions of a page dynamically. Every single one of those AJAX requests, well, I've kind of already covered this, but it's certainly something to keep in mind. It will boot Yi, it will boot Craft, and it will boot all of the plugins that are installed within Craft as well, which means that you can multiply a single page request into lots of page requests inadvertently, even though you think you have a caching strategy in place to avoid all of that, just by implementing these plugin functions. So that's one to watch out for. And that slide should have been removed. So let's just end there. So hopefully that's given you a good overview of the different areas that we can apply caching, the pros and cons of each of those different areas, and also how they actually are working in practice on my little sample site, even though 2 of the demos didn't really work very well. If anybody has got any questions about any of that, feel free to ask me. And I realize I've run over because I've been rambling, as I threatened I would do. So feel free to leave if I have gone way over the amount of time that you have allotted to me.
Cool. Thank you very much, Matt. That was brilliant. That was really, really good.